these identities. And I told y'all that the reciprocal identities and the two identities before this, let me go back, hold on. Let me go back. Well, where are they? There's the reciprocal identities. Told you that those were the first ones that were important. That's not the ones I'm wanting to see. They might show them after the Pythagorean identities. And then there's the Pythagorean identities. There's the Pythagorean identities. So you might want to write those down. And I think we left off in the last class with writing those down. We may not have wrote them down. I might have said, okay, let's stop right here. But those are the reciprocal identities. Now you're going to use those a lot later on. We're going to use them before the unit test. But I need you to write them down for right now. Sine plus cosine is equal to 1. 1 plus tan is equal to secant. And 1 plus cotan is equal to cosecant. Now, Hubert, you're not saying the squares. Well, I don't have to because of the Pythagorean identity. You remember the Pythagorean formula is all squared. A squared plus b squared is equal to c squared. Well, 1 squared is 1. So the rest of it's going to be squared, but 1 squared is 1. So you just have to remember sine, cosine 1. 1 tan secant. 1 cotan cosecant. And if you remember it that way, you know they're squared. It's easier to remember. And they show you basically, and I'm trying to find, okay, they're fixing to show it right now. And there is the two quotient identities. And they are very important. Now, why are they showing you the reciprocal identities, the Pythagorean identities, and the quotient identities? Why are they showing you those now? Because they are the most used. Okay? So sine over cosine is equal to tangent. Cosine over sine is equal to cotangent. Now that's not hard to remember because the tangent and the cotangent are reciprocals of each other. So it's not that difficult. All you need to remember is sine, cosine, tangent. Sine over cosine is equal to tangent. And then you can just flip them, and that's equal to the cotangent. They should have put those in a little box, you know, like they did the other ones. I don't know why they didn't do that. It's them Russians. Now, this one says tan. I'm going to show you how to do this one. Let me get my handy dandy. Where's my whiteboard? Hold on a second. Let me pull up my whiteboard. I had to restart the computer, sorry. There's the whiteboard. New and transparency. And hold on just a second. And whiteboard. Publisher. And current slide. All right, so here is an example of a question. It says, find the sine and the cosine with the tangent equal to 4/3. Well, somebody tell me what the tangent is equal to.
Opposite over adjacent.
Good job. You're the one that listened. Tangent is equal to Oscar had a hunk of apple. So that's equal to 4/3. Now, it says it's in quadrant what? Quadrant 3. So we're going to draw a picture of quadrant 3 right here. 1, 2, 3. Quadrant 3 right there. So we know that the angle is somewhere in here. And we also know that all students take, so we know that the positive and positive, the cotangent and the tangent are both positive. So Oscar had a hunk of apple. Of is 4. So that's the opposite. So that's down here. So that's -4. Hold on. Let me get my eraser. So we know that that's -4, and we know that this is -3. So now we can take our handy-dandy Pythagorean theorem, and we can say -3 squared plus -4 squared is equal to, call it h squared. And that's 9 plus 16 is equal to h squared. 25 is equal to h squared. Did I do that right? And the square root of 25 is 5. Now, what is the sine? Sine is equal to Oscar had, and cosine is equal to Oscar had a hunk. So the opposite is -4 over 5 and -3 over 5. That is the kind of questions I will test you on. Now, I'm not looking for y'all to be masters of identities on the first test. Okay, I want everybody to understand that. I'm looking for you on the first test to be able to mechanically do sine, cosine, tangent, and the other 3. Be able to change a decimal degree into degrees, minutes, and seconds. Be able to change a radian into degrees. Be able to change degrees into radians. That's all I'm going to test you on the first one. I'm not going to ask you to give me a proof or a theorem using the identities on the first test. So I don't want you to harp too much on the identities. I want you to write them down, put them on an index card, put them on a sheet of paper, and laminate it. Do whatever you want to with the identities. We're not going to really get to the identities until the next unit. So I don't want you to spend a lot of time worrying about the identities. So anyway, that's the answer, and that's the type of question I would ask you on a test as far as how to do sine, cosine, tangent. And they're doing it right here, and they're doing it backwards, but you can do it that way. And there's -4/5, and the other one is -3/5. And you can use the Pythagorean identity also, but I'm not really harping on that right now. Okay? If quadrant 4, find an expression for secant in, okay, they're going through the identity, and that's fine. That's fine, but we're not worried about that right now. Go through that. Down here, grade, okay, we'll find the grade of the road. Okay, a downhill highway grade is modeled by the line y is equal to 0.06x. That means -0.06 over 1 in quadrant 4. Okay, so that means in quadrant 4 that for every vertical over horizontal, for every foot or for every 1 unit, you go down 0.06. For every foot, you go down 0.06. For every foot, or for every 1 unit, you go down 0.06. So it's a shallow line that looks something. I don't have a straight line maker here. So in quadrant 4, so it looks something, for every 1 unit, go down 0.6. For every 1 unit, go down 0.6. For every 1 unit, go down 0.6. So it looks something like that. Find the grade of the road, approximate the grade resistance for a 3,000-pound car. Okay, so there's my drawing. Mine's a little bit off, but there's my drawing. And we know for every 100 feet, go down 0.6, multiply by 100, or for every 1 foot, you go down 0.6. However you want to do it, that's fine. You're going to get the same answer, whether you use 1 unit or 100 and 0.6 or 6. however you want to do it. But the main thing is that you understand that the quadrant tells you whether the x is negative or positive, or whether the y is negative or positive. Why are we not worried about the hypotenuse? Somebody tell me why we're not worried about the hypotenuse. That means I want y'all to answer. I want y'all to give me some interaction here. Why are we not worried about the sign of the hypotenuse? Okay, can y'all hear me okay, or?
Yes, sir, we can hear you.
Okay, y'all just don't want to talk to me, is that it, or you don't know?
We probably just don't know.
Well, what do you do to get the hypotenuse? You have to square everything, and what happens when you square everything?
It's always positive.
It's always positive, so you don't have to worry about the sign of the hypotenuse. Write that down if you didn't know it. The hypotenuse is always positive, or it's always a distance unit that's always positive, whatever you want to call it. So the grade is negative 0.6%, or negative 6%. And 106%, we can find R, and then that's going to be 10, square root of 10. That's using, and I'm not going to go through this because that's using the Pythagorean Theorem. So the hypotenuse is the square root of 10,036. That's the hypotenuse. And now you can find the sine, cosine, and tangent. Okay, I'm not going to spend a lot of time on this because it's just like the problem I just gave you. Now, the grade resistance, you're not going to know that, people. All right, so write this down. The grade resistance is equal to R sine theta, basically, or W sine theta. But it's basically asking you for the vector. And the vector is R sine theta, R cosine theta. But here they're saying R is equal to W sine theta. So that means W, which is 3,000, that's the weight of the car, times the sine of the theta, which is negative 6 over 10,000. So you're getting about 180 pounds of resistance going downhill. Okay? Now, of course, that's just starting off. As it goes downhill, that's going to increase. But that's what you're talking about, grade resistance. Okay? Okay, now discard. Now let's go to 9.3. And don't worry, I'm expecting questions. I only got one question from y'all, so that means that y'all understand 9.2. So I'm going on. And people that haven't done homework, I don't know what you're waiting on, but anyway, 9.1 and 9.2 I've already covered. This is 9.3 that I'm going into today, if I can find the dadgum. Hold on a second. Where is my 9.3? I hate when it does this. All right, let me get out of this. There it is. 9.3 is right here. Now, 9.3 is a continuation of right triangles and evaluating trigonometric functions. It's nothing changes. They still call it X, Y, and R. Nothing changes. There's your sine, cosine, and tangent. Nothing changes. But we got our special angles here. And I'm going to pull up the special angles in another way. Let me go here, and I'm going to insert a new slide. And I'm just going to blank, insert picture. I'm trying to impress y'all. That's what I'm trying to do. Let's see. There are the three angles. So I want you to write those three angles down. This is your special angles. That's what they're called. They're called special angles. And it was the best one I could get off the internet. Pi over 6, that's your 30-degree angle. So if you want to put 30 degrees, we'll put 30 degrees. Pi over 6 is 30 degrees. So this is your 30-degree special angle. This is your 45-degree special angle. And this is your 60-degree special angle. Do you need to learn these? Yes. On a scale of 1 to 10, this is about a 15. You need to learn those 3 angles. If you want to say memorize, that's fine. I don't like to use the word memorize, but because if you can do those 3 angles, and you can remember what I told you about the unit circle, then you can do the unit circle and not have to memorize it. Because those are the 3 angles that make up the unit circle: 30, 45, and 60. Now, do you have to remember the 1, square root of 3? Yes. Because you can find the sine, cosine, and tangent of each one. See, your angle's down here because that's where they got the pi over 6. So your little man has got his foot on the adjacent and the hypotenuse. Same here. The angle is right here. The angle is right here. So now you can find the sine, cosine, and tangent. I'm just going to find the sine, cosine, and tangent. So sine, cosine, tangent. And I'm not going to write that. I'm just going to go all the way across. So the sine Oscar had is equal to 1/2. Cosine Oscar had a hunk square root of 3 over 2. Of apple. 1 over the square root of 1 over 2. Right? No, that's 1 over square root of 3. That's 1 over 2. Sorry. Let me erase that. So that's 1 over square root, Oscar had 1 over square root of 3. Now, of course, you know you can't have the radical in the denominator. So we're going to have to take our blue marker and we're going to have to multiply by the square root of 3 over 3. And that's going to give us an answer of square root of 3 over 3. So there is your sine, there is your cosine, and that is your tangent. Now, of course, if you want to turn them around, you can turn them around, and you have your cotangent, secant, and cosecant. 45 degrees. Oscar had. Well, this is O, this is H, and this is A. Oscar had 1 over square root of 2, which is equal to the square root of 2 over 2. A hunk, 1 over square root of 2. And of course, you get the same thing. Of apple, 1. Now, of course, the reciprocal of 1 over 1 is 1. So the tangent and the cotangent are 1. And then you would flip the others and rationalize accordingly. 60 degrees.
I have a quick question for
Yes.
the pi over 6. Why did you make the root 3 the hypotenuse and not the 2?
Because 2 is always your largest number. The hypotenuse is always your largest number.
Okay. So
What's the square root of 3?
it's less than 2.
1.7. Mm-hmm.
So okay.
And I didn't assign those numbers. That's special angles. Okay? I didn't put those numbers there. Those are the numbers that are on the special angles.
Yes, sir. Okay.
I know what you were saying. Why is there a 2 there? I know you weren't saying that I put it there, but that's why there's a 2 there, because 2 is less than the square root of 3.
Yes, sir.
And if you do the math, what's 1 squared plus the square root of 3 squared? That's 4. And what's the square root of 4?
2.
So that's how you get it. Pythagorean Theorem.
Yes, sir.
Okay, anybody else got a question? Now make sure I'm trying to do it, right off the board. So if I make a careless mistake, please let me know. All right, here we go. Opposite. Oscar had A. Okay, so Oscar had, so that's going to be square root of 3 over 2. 1 over 2. And of apple, square root of 3 over 1. And there are your sine, cosine, and tangent for your special angles.
Wait, I'm sorry. I have another quick.
Yeah.
You
Go ahead.
said that root 3 was going to be smaller than 2. So why would 2 not be the hypotenuse?
2 is the hypotenuse. Oh, I'm sorry. I'm
Yeah,
sorry. I see
just-
what you're saying. I see.
Mine is
I don't know where that came from.
Okay.
I guess my dyslexia hits every once in a while. I do have it, so I don't know what that is. It may be just mental illness. I don't know.
You were doing it
Let's
right
see.
when sine was 1.
There we go. How about that? Does that make you feel a little bit better?
Yes, sir.
I appreciate it. Maybe I need to drink some more of this vodka. Maybe that's what it is. All right, so I'm just kidding. I see why you were asking the questions. I don't know why I put A up there with the H. I don't know. Maybe I was just out of it for a second. But thank you. Who was that? Mr. Wexler?
Yes, sir. So then
I appreciate you being attentive. Thank you, and interacting. I appreciate that.
So then all those values would change for sine, cosine, and tangent, correct? Because it would be
Tell me that.
because it would
Yeah,
be,
they would.
it would
Hold
be-
on. Let me fix it. I had it right the first time.
Yeah, you did. Yes, sir.
I don't know why I did that, so I'm sorry. Please go ahead and cuss me out. I'm sorry. Everybody's going, oh, no, I'm gonna reset. You'll be all right. I'm just glad you called it. Oscar had 1/2 A hunk, square root of 3 over 2, of apple, 1 over square root of 3, which is square root of 3, over, let's see, 1 over square root of 3, be square root of 3 over 3. Check me on that. Let's see, of apple will be 1 over square root of 3, square root of 3 over 3. Oscar had 1/2 A hunk, square root of 3 over 2, and square root of 3 over 3. I think I got that right now. Thank you for bringing that up. Yeah, I appreciate one person out of 21 being interactive. Thank you. And Bubba's on the back row going, yeah, man, I knew that was wrong. Shut up. You don't. Hello? Hello?
Yeah, I can hear you now.
Yeah, we
What
can hear you now.
happened?
I don't know.
Oh.
Your sound just went out. I was about to
Okay,
text.
well, I don't know what happened. This board went crazy and everything went blank. It was like the computer cut off, but it didn't cut off. Ms. Patel, I see your question and thank you for being interactive. I appreciate you. You probably brought it up before Mr. Wexler did. I don't know who brought it up first, but thank you, Ms. Patel. I see your chat right there. She probably called it. Y'all probably called it at the same time. Okay, I do not understand what just happened, but all three of my screens just went blank, and I had to go find everybody, so I don't know what happened. My recording is still going, I assume. Okay, so you need to make sure you understand those three, because that's what we're fixing to go into right now. There's your special angles right there. So I'm gonna let you look at them. I mean, you can do the Chevy Chase, you know, at the Grand Canyon and look at them, or you can write them down or whatever, but there's your special angles. Now they're showing you where they come from. Okay, you got an equilateral triangle.
We can't
and
see.
you bust it in half. Can you
We
see
can't
the
see your
screen?
board.
No, sir,
No,
you're not.
Okay, everything turned.
Now your mic cut off again.
Yeah.
No, I do not know what is happening here, but I'm going to try this one more time, and if it goes off again, we're going to come back and I'm going to say bye. Okay, y'all hear me? I don't know what's going on with this thing.
Yes, sir.
I moved my mouse and everything just went kaplooey. Everything just left. It's them damn Russians. Okay, I don't know. Okay, let me go back to present. Let me try to present. I'm moving my mouse really slow because I don't want to do whatever I did. I don't want to do it again.
There it is. We got it.
We
Okay, you got
now.
it? All right. Now let me hit, I'm not going to touch that mouse again. All right, so there is showing you how you get the special angles. Okay, the 30-60, the 30-60 comes from an equilateral triangle. All right, and the 45 is just 45, 1, 1 square root of 3. And there's how you get, and if you turn the 30, if you turn the 30 on its side, the 60 on its side, you got the 30. So that's where the 30, the 45, and the 60 comes from. They come from the equilateral triangle and the 45-degree angle. Now, does anybody have any idea what is special about the 45-degree angle? Anybody? It's used whenever you want to find a 45-degree angle if you're a builder, if you are a carpenter or a builder, and you want to find.
Oh no.
Yeah, I think his mic cut out again.
Yeah.
It's a tough scene.
Yeah, this is rough.
So how was everyone's move-in day?
Busy.
I'm not going to do it.
We lost you again.
I know, I'm not going to do it. It just lost the whole Teams, and then it was off the desktop, and then after about 15 seconds, it just appeared on the desktop again. So I'm going to go ahead, this is what I'm going to do. I'm going to show you this one thing, and just bear with me a second. I'm going to pull PowerPoint back up, and then we're going to quit. So can y'all see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, and I'm going to pull this back up, And I'm gonna hit this, and I'm gonna try to finish this. Okay. I was gonna tell you what's special about my mouse is, look at my mouse.
No.
Did he really just cut out again?
Yeah.
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 It's tough.
Wow, look at his mouse. So interesting.
That's a wrap.
Maybe it's because everybody's up here now.
Yeah, probably.
Everybody's on the internet.
Yeah.
It's weird though that it's working for us and not him.
Yeah, if anything, I feel like it should be vice versa.
Yeah.
I think it's a sign to go.
I think he left.
Oh.
Oh no, he's still in. He's still in here.
Oh, now he left.
So should
He's
I go?
gone. Oh, no.
Oh, he's back.
Okay, y'all have a good day. I'm gonna cut off the recording. Y'all can try to start working on 9.3, but I'm not gonna play this game. So I come to Anderson campus to do this, and I have better look at my house. So anyway, I'm gonna stop the recording right now. Work on 9.3 homework if you can. If not, we'll start over Thursday and try to cover as much as we can. Go ahead and send me some homework questions in 9.3 if you try it. What's your questions?
Oh, I was just asking if you were gonna like record it and then post on your YouTube channel for us to see instead. But never mind.
Okay, I could try that. Let me see if I can finish it at home, or I might go over it Thursday, one of the two. Okay,
right.
but I will tell you that 9.3 is a continuation of 9.2. Only the special angles are in there, and it might ask you to do the unit circle. Okay, but I'm not going to do any more on this computer, so I'm going to stop the recording right now, and I will see y'all Thursday.